Hello everyone. In this question, the Earth of mass is given revolves around the Sun with velocity, angular velocity 2 into 10 to the power minus 7 radian per second. That is also in SI unit. And circular orbit of radius 1.5 into 10 to the power 8 kilometer, which we have to convert into meters. The force exerted by Sun on Earth is. So we know that the gravitational force only they are asking, that must be equal to mv square by r. Why? Or which is equal to m omega square r. Why though? Because it is revolving. It is in the question. It says that it revolves around the Sun. So we are going to substitute that. So this F gravitation must be equal to mass of Earth is given 6 into 10 to the power 24 into omega square we need to consider. So it is omega square 2 into 10 to the power minus 7 square, that is 4 into 10 to the power minus 14. So m omega square into r. What is r value? 1.5 into 10 to the power 8 is there into 10 to the power 3, because kilometer I'm just converting into meters. So this much would be the value. So let's rearrange it. So here we have 10 to the power minus 24, 14. So this is going to be 10 to the power 10. So 10 plus 8 and 3. So it is 13 and 21 is the value. So 6 into 4, it is 24. So 24 into 15 into 10 to the power 20 will be coming. This will be 10, 18, 20. That will be the answer. So how much is 24 into 15? So that will be the correct answer. So 24 into 15, 24, 240, 240, 120, 360 will be coming. So 360 into 10 to the power 20 Newton, or which is equal to 336 into 10 to the power 21 Newton. So what is the gravitational force between them? That is equal to 36 into 10 to the power 21. Again, A for AIIMS is the correct answer. Hope you get it. Thank you. So 1995 NEET question. The radius vector drawn from the Sun to a planet sweeps out equal areas in equal times. All right. Equal lines. All right. This statement this is Kepler's second law. So it says that, look at this, a planet is actually moving from one point to another point. You can see from this point to this point, it is moving. So according to Kepler second law, that is, it actually covers equal areas in equal interval of time. So what is this? Here you can say that dA by dt must be constant. Or here you can say if this is A1 in time t1, this is A2 in time t2, A1 by t1 must be equal to A2 by t2. That's it. Or aerial velocity must be constant. That's what I said. dA by dt must be constant. So this is basically the significant part of this is it actually comes under conservation of angular momentum, or that is the reason why this is actually aerial velocity becomes constant. And I hope you understood that part. It is also called law of areas, and that is Kepler's second law. All right. So option D for doctor is correct answer. Thank you. So in this question, a body of weight 250 Newton on the surface of surface, assuming the Earth is actually a perfect sphere, and uniform mass density it has. How much would it weigh halfway down the center of Earth? So basically we have to do the G with respect to depth. We know that that is equal to G into 1 minus D by R. So basically this G depth will be equal to, the acceleration due to gravity depth is equal to G into 1 minus R by 2 divided by R. So it is going to be G depth is equal to G into R got cancelled. Will be 1 minus 1 by 2 is 1 by 2. So it will be G by 2, or I can say the weight at a depth is equal to R by 2 is equal to weight on the surface divided by weight on the surface divided by 2. So weight on the surface, which is given already 250 Newton. So 250 divided by 2, that is equal to 125 Newton. So the correct answer here it is 125 Newton. So option C for Chennai is the correct answer. Thank you. So the angular velocity of rotation of a star of mass m radius r is given, all right, at which the matter starts to escape from its equator is. So basically, you know that the escape velocity is, we know that, which is equal to root of 2gm divided by r. But here they're saying that we need this same velocity, it is there. So we need the omega for that. Omega is equal to VE divided by R, because V is equal to R omega, or omega is equal to V divided by R, which is equal to root of 2gm divided by R divided by R. So you know that if I take this R inside the square root, omega becomes under root 2gm divided by R square into R, that will be R cube. Very easy question. So the correct answer here it is root of 2gm divided by R cube. So the correct option is D. D for doctor is the correct answer. Thank you. So in this question, it's such an easy question. 1996. What will be the formula of mass of Earth in terms of G, R and G? Alright. So we know that G is equal to Gm divided by R square. So M is equal to GR square divided by G, capital G. So what is the correct answer? GR square divided by capital letter G. That is option B. B for Bombay is the correct answer. Thank you. So in this question, a ball is dropped from a spacecraft revolving around Earth at a height of 120 km. What will happen to the ball? Alright. So the thing is, you look at this. Here, Earth is there and the spacecraft is actually revolving. And what is the velocity of the aircraft? Which is called orbital velocity, right? And then after this, you are dropping a ball from that. And what will be the, I'm just dropping it here. So what will be the velocity of this ball also? The relative velocity with respect to aircraft is 0, or with respect to Earth, the velocity will be orbital velocity itself. So what, with respect to Earth, if it is orbital velocity, then the body which you dropped will also be orbiting around Earth with the same velocity. So the correct answer is it will move with the same speed tangentially to the aircraft. Wrong. It will continue to move with the same speed along the original orbit of this aircraft. Yes. So C for Chennai is the correct answer. Perfect. Thank you. So in this question, this is basically an assertion reason type question. So here all options are given. Actually 5 options are there. Which one is the correct? We will choose. Okay. So it's an AIIMS previous year question. Let's say assertion, the square of time period of revolution of a planet is proportional to the cube of semi-major axis of the ellipse. That is correct actually. Then the sun's gravitational field is inversely proportional to the square of the distance from the planet. So actually you can prove the time period is proportional to you know that the gravitational pull is equal to GMM divided by A square. It is equal to m omega square A, I can take, where A is the semi-major axis, that is average distance or mean distance we are considering, and that is not the reason why it is like this t square is proportional to A cube, but we are just assuming here it is mean distance. Now let's see, GMM divided by A square is equal to m into 2 pi by t the whole square into A. So from that equation, it is very clear that t square is proportional to A cube. So here the mean distance is considered as this one. That's why it is proportional to A cube. And also the distance from the sun, it is keep on changing. But every point it will be t is proportional to the mean distance r1 plus r2 by 2 the whole cube will be considered, and that is the thing. All right, for each planet it will be like that. So here both are actually correct statements, but it is not the correct explanation for that, and that is what is the correct answer. So option B for Bangalore is the correct answer. Thank you. So the period of revolution of planet A, that is time period of A, and around the sun is 8 times that of B. So TA is equal to 8 times that of B. the distance of A from the sun is how many times greater than B? All right, fine. So we know that TA by TB, the whole square is equal to RA by RB, the whole cube, from Kepler's third law. So I can write TA by TB already given, that is 8, which is 8 square is equal to RA by RB, the whole cube. All right. So what is that 8 square? It is 64. 64 is equal to RA by RB, the whole cube. And what is RA by RB? RA by RB is equal to cube root of 64, which is going to be 4. So the correct answer is 4. That is it. Option A for AIIMS is the correct answer. Thank you. So we have AIPMT 1997 question. So the escape velocity of a body on the surface of the Earth is 11.2 kilometer per second. If the Earth's mass increases to twice its present value and the radius of the Earth becomes half, the escape velocity becomes. So we know that the escape velocity formula is root of 2gm divided by r, where m is mass of Earth and r is radius of Earth. And here in this question they said that the value of mass becomes twice. So g is a constant. So 2m divided by, and radius becomes half, r by 2. So this is going to be V escape is equal to, this 2 will come on the top. So 2 into 2, 4, root 4 is 2. 2 times root of gm by r. That is 2 times of what is the escape velocity, the original escape velocity of present Earth. So which is equal to 2 into 11.2 kilometer per second. So the correct answer is 22.4 kilometer per second. So which is the correct answer? Correct answer is A. A for AIIMS is the correct answer. I hope you understood. Thank you. So if a mass of a body is m on Earth surface, the mass of the same body on the moon surface will be, yeah, this is very easy question. We know that, so moon is actually a smaller than Earth. The mass is less, the radius is less. So the mass on the surface of moon will be m by 6. Correct? Yes. I'm just kidding. It is not m by 6. It is m. Because g of moon is basically g by 6. G Earth divided by 6. So, or weight on the surface of moon will be weight on the surface of Earth divided by 6. This is all okay. But here they are actually trying to take this idea and making us, they are trying to confuse us. So what is the thing? The thing is here mass is not going to change, right? Mass will be same. Okay. So mass of the body on the surface of moon would be, it will be m. Okay. So correct answer is A. A for AIIMS is the correct answer. I hope you understood. That's it. Thank you.